All right, my Math 40 plus students, today we are going to be going over a problem, this particular one from section, let's see, we're in section 5.2 right now. We're going to close out with classroom example 5 first, and then we're going to move into 5.3 and 5.4. I think I probably will stop there and then just wait until Wednesday to go into 5.5 and 5.6. That'll end us on chapter 5 pretty nicely, and then we'll get started with chapter 6 next week. So this is the perspective schedule for this week. There is an activity that's going to be taking place for the second portion from 2:30 to 3:30 approximately. It'll cover some helpful tips, algebra tips of how to deal with these types of problems. Okay, let me go ahead and clear that out. I'll be putting this recording up later. So if you are watching along, you don't need to actually jot anything unless it's helpful. Okay, so the first thing we discussed last time in sections 5.1 and 5.2, how we can verify identities. So one of the first things that I mentioned was drawing a line down your page where that equal sign is, and then just realizing that you can't cross this line. Okay, with algebraic steps. And instead, what we're going to be doing, we're going to simplify either the left-hand side to look like the right, or the right-hand side to look like the left. Okay, that's still an ugly look. There we go. Okay, so I'm going to go ahead and save a picture of this part, and then I'm going to clear this portion out so that I can get started. We already discussed if we start on one side and we make it look like the other. We briefly discussed that we can also have a third expression that both sides are equal to. So we're going to discuss how to work with both sides today. All right, so bear with me. I have all kind of windows and things open that keep popping up and all kind of nonsense, as always with the technological issues. Okay, so first thing I'm going to do, I'm going to start on the left-hand side because it looks like there's some nice factoring that we can do on the top here. And sorry, that should have been right-hand side that I wanted to start with. I'm going to start with the right-hand side. And the first thing I'm going to do is start with this top portion here. So if it helps, you don't have to do this part. You could just factor it directly, but let W equal cosine alpha. By the way, this little sign here is an alpha, Greek letters, lowercase. Okay, so if I let W equal cosine alpha, then what I get from this numerator here is 1 minus 2W plus W squared. And you can rearrange that to be W squared minus 2W plus 1. You can factor using either trial and error, box method, or AC method. If you need help with those, let me know. I can bring some extras. As a matter of fact, I think I have a worksheet for factoring next week that I want to bring in. What this comes down to is W minus 1, W minus 1, which is W minus 1, the quantity squared. So this top part actually becomes cosine alpha minus 1 squared. Okay. That's still divided by negative sine squared alpha. So then we'll tackle the negative sine squared alpha off to the side here. There's a few ways you can do it. You can do it with algebraic manipulation. So for example, I know that cosine squared alpha plus sine squared alpha is equal to 1. So try to isolate a negative sine squared alpha. I'm going to subtract 1 from both sides. Actually, sorry. I'm going to subtract sine squared alpha from both sides first. And then I'm going to subtract 1 from both sides. So what I find is that negative sine squared alpha is now equal to cosine squared alpha minus 1. And on the top, I still have my cosine alpha minus 1. It's squared, but I'm actually going to break it apart strategically here. So we have 2 of those factors. And the reason I'm going to do this is because cosine squared alpha minus 1 is factorable. Similarly, if I let W equal cosine alpha, I have W squared minus 1. This is a difference of squares, which is also factorable by these upper methods here. If you change this to W squared plus 0W minus 1. But you don't have to do that. If you remember your difference of square formulas. So this comes out to W plus 1, W minus 1. Remember, W is cosine alpha. So what this bottom part here becomes is cosine alpha plus 1 times cosine alpha minus 1. And on the top, we still have the same thing. Cosine alpha minus 1 times cosine alpha minus 1. We see one of these will cancel. And then this is the form cosine alpha minus 1 over cosine alpha plus 1 that we're going to try to match. So let me call this star. So this is the third expression. I want to get the right-hand side to look like this expression, and I want to get the left-hand side to look like the same expression. Go ahead and take a picture if you need to of that, because I'm going to clear out all the stuff on the left-hand side of the screen, and we are going to start maneuvering the left-hand side of our identity here to look like the stuff in blue. Okay. So now we're going to work on the left-hand side here. Let's do this in dark green. So for this, we're actually going to write our expression in sine alpha and cosine alpha terms. Oh, come on. Let's see, right? Our expression in sine alpha and cosine alpha terms, then simplify to get the expression in blue. Okay, so over here, remember cotangent is cosine over sine, and you still need the argument of alpha in there for both. Minus cosecant alpha, that's 1 over sine alpha. Cotangent alpha shows up again. Plus cosecant alpha, 1 over sine alpha. Okay, the LCD for the top is actually the same as the LCD for the bottom here. The LCD is sine alpha on the top, and the LCD is sine alpha for the bottom. So this is, remember, what's called a complex fraction, because there's some fraction stuff in the numerator that can be simplified and fraction stuff in the denominator that can be simplified. So this LCD we're looking at is right here. So we actually don't need to change. Hold on one second. Okay, here we go. So we actually don't need to change the denominators in this case. Both the denominators are the same on the top. So we're going to combine our fraction with sine alpha as our denominator. And then on top, we still have cosine alpha minus 1. Okay, and then on the bottom of our complex fraction, we're going to have cosine alpha plus 1 divided by sine alpha. Now remember the trick. I went over this in the last video. Please review it if you need to. You can write this as an old school division. So the sine alphas will cancel out. And then what we are left over with is cosine alpha minus 1 from the numerator of the complex fraction divided by the numerator of the denominator of the complex fraction. I know it sounds a little confusing, but, and here we are. We got the left-hand side to look like our third expression, and we got our right-hand side to look like our third expression. Once they match, we're done. Let me save that, give you a minute to take a picture in case you need to. And then I will take a short pause here. All right, you guys, so we're going to learn about some new formulas in 5.3 through 5.6. For 5.3, we're first going to start with the sum and difference identities for cosine. I'm actually going to teach you a song for this and 5.4 that might help you. 5.4 is sum and difference identities. For sine. excuse me, I believe tangent's in there as well for 5.4, but we're going to learn that we can just make ratios of sine and cosine, and that'll take care of the tangent and stuff to avoid having to learn more formulas. All right, so let me go ahead and just get into this first part, and then once we get down to the box, we'll have a song. So difference identity for cosine, you can actually find the proof of this in your book. I'm not going to go over it because it's kind of long and confusing. But essentially what I really want you to get from this, what this part is saying right here, cosine of A minus B as an argument is not the same as cosine A minus cosine B. Okay. So we actually have an example here of this that kind of helps us to see what happens. If we have A as pi over 2 radians, and we have B as 0 radians, then we want to double check, what does cosine of A minus B come out to? So this is going to be our left-hand side here. And this part underneath is going to be our right-hand side. Right here. So let's plug in and see what happens here. So cosine of A minus B, that's going to be cosine of pi over 2 minus 0 cosine of pi over 2 minus 0 is going to be the same thing as cosine of pi over 2. And remember from your unit circle, here's pi over 2 radians. What would the cosine value be there? It'd be 0. So you actually get 0 for your left-hand side. Now let's check that with the right-hand side. If we have cosine A minus cosine B, that's cosine of pi over 2 minus cosine of 0. We already saw what cosine of pi over 2 is. That's going to be 1. And then cosine of 0, for 0, remember that's going to be right down here, 0 radians. The point there is 1, 0. So the cosine value would be, oops, sorry, my bad. Let me go back a little bit. That's my bad. Okay, so my mistake is here because we just wrote it differently here, my bad. So let me go back to this step here. So cosine of pi over 2, be careful. It should be 0, which we just found out from here. Now, if we're looking at 0 radians, the point is 1, 0. The cosine value is here. So that would be a 1. So we have 0 minus 1 that we're evaluating, that becomes -1. So what we found is on the right side, this would be cosine pi over 2 minus cosine of 0, which is 0 minus 1, -1. We see that 0 is not equal to -1, so we've shown that cosine of A minus B is not equivalent to cosine of A minus cosine of B. In every case, it's not an identity, okay? Go ahead and save a picture of that if you need it. Essentially, we find that what cosine of A minus B is actually equal to is cosine A cosine B plus sine A sine B. And then that's what's called the difference identity for cosine. The sum identity cosine A plus B is going to be cosine of A, cosine B minus sine A, sine B. Okay, so we can write this here if we want to, but I'm actually going to write it off to the side. Let me save this picture. I'm going to clear all this out. Okay, so here's a good way to write this. Let me see if I can move over without messing up everything. Okay, so a good way to write both the sum and difference identities at the same time. So we're going to have cosine A, B, and let me color code a little bit. Let's make drastically different colors. Okay, we're going to put our equal sign, and then for both cases, we're going to put cosine, oops, let me leave that part off for a moment. Put your A and your B. Leave some space, put another A, space, and then put another B. So the A's and B's are going to be in the same order throughout your entire identity. Now, essentially, the first part of the song, we'll get to that in a moment, but I'm going to want you to remember is cosine, cosine, sine, sine. Kind of bad form there. Cosine, cosine, sine, sine. So cosine, cosine, sine, sine. And then we're going to put our actual sign between the positive or negative value. So sum, difference. For cosine, right in the middle here, you're going to put the opposite. Okay. What that tells you is if you read the top, cosine A plus B, you're going to use cosine A, cosine B minus sine A, sine B. If you use the bottom, cosine A minus B, you're going to use cosine A, cosine B plus sine A, sine B. So this combines the sum and difference identities for cosine. Okay, now before I get too far, I'm going to go ahead and combine the sum and difference identities for sine as well. So we're going to have sine okay, and then we're going to have AB going to have that same pattern, A, B, A, B. Now what we're going to do, we're going to say, okay, the second part of the song. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Okay. Put your plus minus here. The difference between cosine and sine for these identities, aside from the order of cosine A, sine B, and such, you're going to have plus match plus and minus match minus. Now, the one other thing I need for this song to do it properly, it's a song that I actually learned when I was taking trigonometry. a long, long time ago. Okay, let's see if I can move this flawlessly. Yay. Okay, so here's the song. The song pretty much tells you the order if you have the sine, sum and difference identities, and then the cosine, sum and difference identities, what your form should be. Okay, so here we go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. One more time. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. So what I want you to do, if you still need this, take a picture of it. I'm going to save that and clear it out. And then I'm going to go over how that song will help you to remember your identities by actually doing. And then we're going to get into some more problems. Okay, so let me go ahead and clear all this out. And then this time, just to save some time, I'm not going to color code the whole thing. If it helps you when I take a break, let me know to color code, and then I will go back and do that. All right, so here's how my song would work. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay, then I know A, B, A, B, A, B, A, and B. Okay, I'm gonna go ahead and put my equals here. Then I say, oh yeah, on the top, sine, cosine, cosine, sine. It's gonna be my sine terms. And cosine, cosine, sine, sine will be the cosine terms. A first, B second, A first, B second. Put your plus, minus, and then sine, same signs, plus, minus. Cosine, opposite signs. Let me save that, and then because I kind of threw a lot at you right there, let me pause my recording and check in. Okay, so we have our formulas over here. So now we're going to learn how to use our formulas in various different ways. Let me go ahead and clear this out. And we're going to get into our first example. The example that I want to get into is actually going to help you for your quiz. It's this one. Excuse me, find the exact value of the expression that's given here. So I'm actually going to do this off to the side so I have more room. Okay, so this is section 5.3, classroom example number 1B. You have cosine of 17 pi over 12 that you're trying to evaluate. So it's not obvious at this point probably, but what you need to do is split this guy up. Because if we try to evaluate cosine 17 pi over 12, that's not a nice unit circle radian value. So what we're going to do is off to the side, split 17 pi over 12 into two fractions. And you want those fractions to be nice unit circle values. Okay. So it won't be as intuitive at first, but definitely just practice with it and let me know if you need help with it. So 17 pi over 12. So an example that doesn't work, I'm going to write it in red. I could say that this is 11 pi over 12. plus 6 pi over 12. If I add these up, I still get 17 pi over 12, so that's perfect. And if I simplify this part here, 6 over 12, that gives me 1/2, so that'd be pi over 2. That is a nice unit circle radian value, but the problem is that this is not the 11 pi over 12. Okay. So instead, what we're going to do is take 17 pi over 12, split it into 8 pi over 12 plus 9 pi over 12. Okay, 8 pi over 12 simplifies to 2 pi over 3. Perfect. And 9 pi over 12 simplifies to 3 pi over 4. Perfect. Okay, so what we find here is that cosine of 17 pi over 12 can be turned into cosine of 2 pi over 3 plus 3 pi over 4. Now, don't get too creative here and start like canceling things out like, oh, I know what cosine of 2 pi over 3 is, or cosine of, Remember, you want to use your identity first, okay? So if you need to take a picture, go ahead and do so. I'm going to clear out this portion so I have more room. And it takes a while. Okay, so this is where our song comes in. We have the cosine sum identity. So we're going to sing our song, sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay. Remember, the second part of that song is for the cosine sum and difference identities. So we're going to have our A, B, A, B, and since it's cosine with a plus right here, so since there's a plus right here, there's going to be a minus in the formula. Okay, so the sum identity comes from the sum part right here, and there's actually going to be a minus in the formula. Okay. So if it helps to see, this is the same thing as cosine of A plus B. I don't know why I wrote that so small. It's just all deleted. Yay. Okay, so sorry, one more time. Okay, so that's what our song helped us with. Now we already have the left side, right? We know what A is. And we know what B is. So we fill in our formula. So cosine, cosine, sine, sine. We're going to put the minus sign between. And then A, B. A, B. And then hopefully you can see this, but there's a multiply between. So you're actually going to be doing these multiplications before you do the subtraction. Now, this is when you need your unit circle knowledge, okay? For 2 pi over 3, that would be right about here. And its coordinate is located at -1/2 root 3 over 2. Okay, so what that means is, remember, this is the cosine value. So this first portion turns into -1/2. This second portion here, sine 2 pi over 3, comes from the second part of the coordinate here. So this is going to become root 3 over 2. And for b, that's 3 pi over 4, right in the middle here. It's located at negative root 2 over 2, root 2 over 2. So this part here becomes negative root 2 over 2, and this part becomes positive root 2 over 2. So now what are we evaluating? We have the -1/2 times negative root 2 over 2 minus root 3 over 2 times root 2 over 2. Multiply straight across, you get negative times negative, that's a positive. You get root 2 over 4. So the subtraction sign, and then here, when you multiply roots together, remember you need to multiply the stuff under the radical together. So that's root 6 over 4. So we combine that since they have the same denominator. And this is what we get for cosine of 17 pi over 12. We save that. I don't see any questions popping up yet. So I'm going to go one more of these problems through. And then I'll double check and see how you guys are doing. If you do have some questions or something, just take a picture of the screen and you can refer to those when I bring it back up. Okay, so let me clear this out. And then let me try to maneuver between pages again. There we go. Okay, the cofunction stuff, I'm not asking you anything specific about this on your quiz or exam. We've already gone through this in a previous chapter before. Essentially, like for cosine, its cofunction is sine. Okay. Remember, that just means that sine theta is equal to cosine of 90 degrees minus theta. I think before we saw it like cosine of B equals sine of A, where A plus B is equal to 90 degrees. If I solve for B and plug back in, I get the same formula here. So I'll leave that off for now. There's more important things to cover. Let me clear this out. Another problem that is similar to one on your quiz is here. Classroom example 3. Write cosine of 90 degrees plus theta as a trig function of theta alone. So essentially, when it says theta alone, it's saying, I don't want this 90 degree part to be showing up anymore. I know that there's a sum identity for cosine that I can expand from this. So you see the summation there. So sine, cosine, cosine, sine, cosine, cosine, sine, sine. Then A in this case is going to be 90 degrees. Actually change this color here. Okay, so A is going to be 90 degrees. And B is going to be theta degrees. Okay, so if 90 is in degrees, theta will also be in degrees too. You do not need to go into radians for this part. You'll see why in a moment. All right, so we had cosine A, cosine B, and then we had sine A, sine B, and then remember if there's a plus here for the cosine sum identity, you want to put a minus between. Okay. Now, cosine of 90 degrees, if it helps you, and draw off to the side. 90 degrees is right here. That corresponds to the point 0, 1 on the unit circle. So cosine of 90 degrees is 0, and sine of 90 degrees is 1. So that tells you 0 times cosine theta. That's going to be cosine theta. And then 1 times sine theta. Oops, sorry. Why did I do that? Bad me. Let me say it again. 0 times anything, right, is going to be 0. So let's write a 0 over here for this whole part. And then we're subtracting. We have 1 times sine theta. That's sine theta. So 0 minus sine theta, that's going to be negative sine theta. Now we have a trig function of theta alone. All right, so far so good. Let's see. I have 2 more problems that I want to go through. I think what I'll do is leave off the other 5.3 one for right now and just go into 5.4. That way you guys have an idea of what you're going to need to do from there. Save. Okay, so far so good. All right, I'm going to clear all this out. So I'll get into the identity one later from 5.3. Let's move to 5.4. There are 2 problems that I want to discuss. Here we go again. All right, let me pause recording. All right, so after fumbling around with those pages, I'm actually not going to go into the first part of these boxes up here. Well, not this first box anyway. This box, you can actually use a formula sheet to help you fill out. One thing that I really want you to be comfortable with at this point is just knowing that tangent is a ratio of sine and cosine. So whatever the argument is, you'll keep it. So tangent A plus B is the same thing as sine A plus B over cosine A plus B. And similarly, tangent A minus B, that's going to be sine A minus B over cosine A minus B. Let me fill it in just for good measure, and if it helps you can use it. Tangent A, tangent B, 1 tan A, tan B, so plus and a minus here. I had a student come up with a song for this before, which was interesting. It was tan, tan, 1 tan, tan, but you don't have to use that if it's not comfortable. And then just to save some time, if you have a minus here, this becomes a minus, this becomes a plus. I'll talk to you guys about some formula sheet stuff a little bit later. Okay, so let's just do one so we can get into the activity. We're going to do classroom example 1, part C. This is actually similar to what we did for our first classroom example of this group today in 5.3, but I do want to cover part C because you have one that's similar in your quiz. So here you have tan, tan, 1 tan, tan. That gives you an indicator that you're going to be using a tangent sum or difference formula. Tangent, like sine, shares signs. So if you have a plus on this side, you have a plus on the top and then minus on bottom. So you see that for this, we have a minus on top and a plus on bottom. So that's an indicator that this is going to be a difference identity for tangent. So my A in this case is 100 degrees. B is 70 degrees. I have the right-hand side of this formula right now. So the left-hand side would be tangent A minus B. Okay. Tangent, simplify your A minus B, and then use your unit circle values. That would be root 3 over 2. So you're going to have a sine divided by cosine. Can't see that. Let me do one more step. That's 1/2 divided by root 3 over 2. Which gives you 1 over root 3, which is root 3 over 3. Okay. So I'll save that for now. That's the gist of what I want to cover from 5.3 and 5.4. Where I'll start on Wednesday is covering a few more 5.3, 5.4 problems, just in case there's any that might pop up on your quiz that you might be struggling with still. And then we are going to get into 5.5 and 5.6, and we'll be done with chapter 5 by the end of this week. All right, let me go ahead and pause recording.